Hi folks, welcome to video number 60. This one is harder proof, so first in the higher section of algebra that I'm going to be looking at. And the key word here is proof. Now when you prove something algebraically, you have to prove things through using letters and numbers, basically. So what we're going to do is we're going to use algebra to prove, and we're going to employ all the skills that we have learnt so far up to this point to do that. Alright, and that would be expanding brackets, collecting terms, rearranging, factorising possibly. So we know, and this is the two key bits here, we know, right, that for certain in the world of maths we can represent an even number using 2n. Alright, because any number, whatever that number is, could be 7, could be 59, could be whatever you want, right? Any number multiplied by 2 will always be even, right? Because you're multiplying it by 2. So 2 multiplied by n, 2n, is our even number, right? That's our base, that's what we're going to work from. Therefore, an odd number can be represented by 2n plus 1, alright? Because if you added 1 to any even number, you would always get an odd number, okay? So we're able to represent any number using the expressions for odd and even numbers, even and odd numbers. It can be it can be squares, and you'll see that in question 2. But it all revolves around knowing that an even number is 2n, an odd number is 2n plus 1. Alright? Not everybody always uses that, but that's what I go with, right? Now, in question 1, we have to prove this, right? Is a multiple of 3 for all positive integer values of n. Now, it sounds really complicated, but actually, it's just multiplying some double brackets out and then collecting some like terms and then seeing what you end up after you factorize something. Alright, so I'm going to multiply out my double brackets here. Now you could employ the grid method of multiplication there, the double bracket method that I've got a video on, right? And if you don't know what I'm talking about, watch the video. So this one I'm going to do without the grid because I haven't really got enough room to draw it in, but you will. So 5n multiplied by 5n. So this is this whole bracket here, this first bracket I'm looking at. I'm going to square it, which means multiply by itself. So I'm doing 5n times 5n, I'm getting 25n squared. And then I'm getting 2 and multiplying it by 5n, and then I'm doing the same thing again. So I've got 10n plus 10n. So it's going to give me plus 20n. And then I'm going to do the 2 times the 2, which is giving me a plus 4. Alright, so this bracket squared is this expression here. Alright, now I've got minus, I'm going to put minus in, and then I'm actually going to pop that in some long brackets, right? Not that I really have to, but I'm going to pop this in some long brackets because I do have to. Alright, now ignore that negative on the outside, we'll deal with that afterwards. We've got 5 squared, 5n squared is 25n squared. That's a 2, there we go, 25n squared. Then I've got the 5n multiplied by the minus 1 twice, so minus 5n minus another 5n is going to be minus 10n. And then I've got minus 1 times minus 1, which is a positive 1. Alright, so really this is where it gets a bit tricky, isn't it, with the positive and negative numbers. And then you close your bracket up. Alright, and now, because there's a negative, and I've taught you about this as well, if there's a negative on the outside of a bracket, everything inside here, we're going to change the symbol in front of it. So I've got 25n squared plus 20n plus 4 stays exactly the same. But minus 25n squared plus 10n minus 1, right? Now that's really important, otherwise you won't get to prove what they want you to prove because it won't work out. So let's collect together everything that we can. So we've got 25n squared minus 25n squared. Oh, there's no n squareds. Then you've got 20n and you plus 10n, and that would equal, and I'll put some identity symbol there. So we've got 30n, right, because adding the n bits together, and then the number bits together, plus 3. Oh, that's good, because what we have to do, we have to prove it's a multiple of 3 for all positive values, or positive integer values of n. That just means whole numbers that are more than 1, right? Now, or more than 0 even, could be including 1. We just factorise this, that's all we have to do here. So we're going to factorise, and again we could use the identity symbol for that because it's just another way of writing the same expression. Take the factor of 3 out, so 3 goes in there, open the bracket, 10n plus 1, right? Now that number being there on the outside, and I'm going to have to go outside the box for this, but you wouldn't be able to do that in an exam paper. So that 3 there proves that this is or all of this is a multiple of 3 for all values of n. Whatever you put in there, you'd times it by 10, you'd add 1, but then you'd have to multiply it by 3. All right. So therefore, 3 dots, right, multiple of 3. All right. That's what that 3 on the outside of our bracket is proving. We have proved it, and we've just summarized it with a little statement. These 3 dots mean therefore, right, in a little triangle formation, therefore multiple of 3. Boom. Done. Okay. So there, it's tricky. There's a few bits where you could fall down, but it's just some piecing together of maths that we already know how to do. And if you don't already know how to do it, go back and watch those videos, please. Now, question 2. We've got to prove that the sum of the squares of any 2 consecutive even numbers is always a multiple of 4. All right. So thinking back to what we just did, right, we're going to need to have a 4 on the outside of a bracket at the end of it, right? And that's going to prove it's a multiple of 4. Even numbers are represented with 2n. Consecutive means one after the other. All right. So you're going to have one that's represented by 2n. And how can we represent the other one? Well, if we add 2, then we're definitely going to be getting the next even number. All right. So I'm going to use 2n, and I'm going to use 2n plus 2. Okay. Because that's our even number. That's what we're representing an even number with, always. And this is the next even number in that number sequence. Now, it doesn't matter what that even number is. All right. It's just the next one because we're adding 2 to it. All right. If we added 1, it would be the odd number. All right. So I'm going to prove that the sum of the squares of any 2 consecutive even numbers is always a multiple of 4. All right. And the sum just means when you add things together. So I'm going to have to add these together, but I'm also going to have to square them because it's the sum of the squares. So I'm going to put that in some brackets. I'm going to square it. I'm going to put a plus, I'm going to put that in some brackets, and I'm going to square it. All right. Now let's see what we get when we work it all out. Now 2 squared is 4, n squared is n squared. That one was easy. This one, double brackets again. So I'm going to put plus, I'm going to pop that in some long brackets. I'm not going to worry about the 4n squared. All right, so I've got 2n multiplied by 2n is 4n squared. Then I've got the 2n multiplied by 2, so that's going to give me 4n. And then I've got to do that again, so that's another 4n. So together that's 8n. And then I've got the 2 times the 2, which is plus 4. Okay, close that. I've multiplied that bracket out. Multiplied it by itself. Okay, so that was us squaring the 2 brackets. That bit's done. Now we've got to add the 2 results together. Basically, that's just 4n plus 4n squared plus 4n squared. That will give us 8n squared plus the 8n plus the 4. Okay. Now let's see what that gives us if we factorize and take a factor of 4 out like we know we need to. All right. And this could go into double brackets again, but I think all we really need to do is just show that the factor of 4 comes out of all of this. All right. So we've got 4, and then we're going to open up the bracket and put 2n squared plus 2n plus 1. All right. And again, it does not matter what that value of n is at all. We can put any number in there, and it would always have to be a multiple of 4 because we've taken factor of 4 out. All right. We would be multiplying whatever this would equate to be by 4, and therefore it's a multiple of 4. So we just summarize it again. Therefore, multiple of 4. Please do that last bit. All right. It makes it nice and neat and tidy, and it proves to the person that's marking your paper that you know exactly what you're talking about. All right. Move myself over. Let's have a look at question number 3. Right. On this relatively tricky topic. So ABCD is a parallelogram. CP is equal to CQ, so there's CP and there's CQ, and that's already labelled on the diagram, and we can see that it's already labelled that it is a parallelogram as well, because those arrows mean that they're the same length and they are parallel to each other, and so are these two. Okay. Now, this sort of proof requires, it's not necessarily all understanding of algebra, it's understanding of geometry as well, shapes, and the properties that these shapes have. We've got to prove that x equals y. Okay, so we've got 2x over here and we've got y over here, and where do we start, right? Well, you can start anywhere really, right? Now this is about understanding that in a parallelogram, I'll just draw that angle there, that the opposite angles in parallelograms, well, they are equal to each other. This one and this one would be equal as well. We could write expressions for those. We don't need to, right? So I'm just labeling that opposite one there 2x, right? You could put the notation that angle BCD equals 2x, okay? If you really, really wanted to. I quite like doing that. Now, they do accept the work on the diagram as well. Kind of, you're just showing that you do understand that those are the opposite angles are equal. Now this one, we need this angle here, because what I've noticed is that this is a right angle, this is a right angle, this is an angle we've got an expression for. We need an expression for this one. And what we could get when we add all of these together is a total of 360, because they are angles round a point. There we're going to be introducing a number, and there we might be able to do something. Okay. So let's look at this expression here. Angle PCQ. Angle PCQ is equal to. Now, this is an isosceles triangle. So this is y, right? That angle there is y. This angle, right, would be 180 minus those two y's, because the whole angle's inside here would add up to 180. So I'm going to label that 180 minus 2y. Okay. Now, let's look at the whole thing here, this whole angle around this point C. All right. We've got 90 there, 90 there. All right. Together, those two would add up to 180. All right. And then we've got this angle here, which is 180 minus 2y, and this angle here, which is 2x, and all of it adds up to 360. So I'm just going to plonk all of those things together. These two, which are 180, plus 180 minus 2y plus 2x is equal to 360. All right. Now this is starting to look like some proof that we're interested in. This is 180 plus 180, which is 360. All right. So if we took away 360 from this side, we'd have to from this side, and we'd be left with 2y or minus 2y plus 2x equals 0. And then we could move the minus 2y to make it positive on the other side, and we'd end up with 2x equals 2y. And then what we'd end up with, if we divided both sides by 2, would be x equals y. Okay, and there's our process of getting the thing that we needed to get. Okay, and it all revolves around understanding the properties of shapes, the angles inside of different polygons, and understanding how you can write expressions for different things. All right, particularly tricky question for sure. Probably more than grade 6 worth of difficulty. All right, but there you go. That's it. We're piecing together everything that we know about algebra, and sometimes we have to include our understanding and knowledge of shapes things. Right. Number 3 is always going to be the more difficult question. So please do continue to watch as many videos as you possibly can. All right. At the moment, the time of recording, we're in some difficult times, I think. So please don't feel like you're going to just give up on things. All right. Just continue and work hard, and it will pay off. All right. People can succeed and achieve things if they put their mind to it. All right. So there will be a link in the description. You can click that, like the video, subscribe to the channel, make sure you're updated with everything, and I'll be posting more regular updates soon. So take care of yourselves, look after each other, and I'll see you next time.